Hello, everybody. So what this video is it's going to be a week 2 lecture video. And so you can see that it says week 2 lecture notes right here. And yeah, that's what we're going to be covering today is the material in this set of lecture notes. So this is also linked in the week 2 lecture page, which should be the home page that you see. However, it will be linked there in the future because I haven't written that yet. So, with that said, we're just going to go through this. Now, one thing you might want to notice is that in the different sections here, I have links to the Zero to MATLAB book, and that doesn't go to the exact right section, but maybe I'll change that later. But right now, it just lists the section and has a link to the textbook. So if you're looking for more information about each of these things, that's where it is. So, yeah, maybe we can, I don't know if I can fit these both on the same page. We don't need Reddit. We do need Octave. So I've got Octave already open and we'll try to fit it in here, see how it goes. Maybe I can make that smaller and make this a little bigger. Maybe. All right, we'll try this. Maybe this is going to be legible. Um, All right, so I already have Octave open, and you can see that I'm in a particular folder that I've, emptied out so that I can go ahead and get started here. And so our first topic today is going to be basic input and output. So from last time, what we did, sorry, moving Zoom stuff out of the way. From last time, you'll remember that we can have variables in MATLAB. Like I could say uh, x equals 5, right? And then up here, you can see x equals 5. And you can see that show up in the workspace as well in Octave. And yeah, so we can have variables, right? And so I think we did something like this last time, where we created a script, which if I go to File, New, New Script, I can create a new file here. And in this file, I can type um, weird. I think I have the colors weird in here. I think there's like line numbers are missing. I could try to fix that momentarily. You know what I'm going to do is I'm going to try to fix it. So I'm going to pause this here. All right, and we're back. Um, so all I did was figure out how to change the colors so that the line numbers were showing up here. All right, so last time what we looked at was we could put variables in our script, right? Like, so if we imagine we were doing an example where I wanted to, let's say, compute uh, compute the area of a triangle, right? If we want to compute the area of a triangle, we could do something like this, right? I could say base equals 5. I'm going to fix the fonts again. Back in a second, hopefully no time at all for you. Oh, okay. I think we started again. Okay. So hopefully that wasn't any time for you. I just kind of fixed the font to be more visible here, although I guess that number doesn't look that visible. All right. So anyway, when we were trying to like do something like compute the area of a triangle, you could say base equals 5, height equals, I don't know, 3. And then if you wanted to compute the area of the triangle, we would just remember the formula that said that the area of a triangle was 1/2, right, times the height times the base, or the other way around. And, I could put semicolons on the end of the base and the height because we don't need to see them. I can save this file as something. So file save as, and we'll just save it as my script.m. See, there it is. And we can run it. So if I click the play button, we should run it. And we can see the variables exist. And if I head over to the command window, we can see that it says area equals 7.5, which is what we wanted, right? But we're just using this in a very basic way because um, these are hard coded. So the user who runs your script didn't have a chance to type them in. And the way that we're outputting the area was just, I left a semicolon off, right? We know that if you put a semicolon, the output is suppressed. And if you take away the semicolon, then, it shows up, right? But we can manually decide what to display and what not to display. So the first thing we're going to learn about is the input function. So over here, um, didn't let me change the size. The input function allows the user to type in a variable. So instead of just saying like base equals 5 here, we can change this to say input. And it's a function, so we have to use parentheses. And then in those parentheses, to call this function, you use it the way it says here. So you can see that they've got a string and they use single quotes and then enter your age, and then they close it with a single quote. And so what goes in there, that is the prompt that you want the user to see. So if I use input and then I say enter the triangle base, and then I could put like, well, that's actually fine. I could put like a colon in a space and then close that quote. And then now what'll happen is when I go to run this code, so I'll save it um, and I'll run it manually here by typing my script. I didn't spell it right. And I still didn't spell it right. Wait, yeah, I did. But it says area equals 7.5. I guess I didn't save it. File, save. Oh, undefined. Okay. Took a few tries, but we ran it. So now you see it says enter the triangle base, and it has a cursor where I can type in the base. So I could say that the base is 8, then hit enter, and the base is 8. Cool. Let's go back over here. Now, we're not seeing anything though, right? Because what happened was this command ran, and the base was 8 because I typed in an 8. And then afterwards it said base equals 8 because I didn't have a semicolon on the end of this. If I have a semicolon on the end of this and I run the script again, I don't know if it saved it. Let's do file save. Run it. It says enter the triangle base. If I say 8, we don't see anything, right? Because our script is not outputting anything yet because I have semicolons on the end of these things. So we can use an input command for the height. I'm going to change the color again, so be back. All right, and we're back. But just change the colors to make them a little brighter. So if I wanted to use the input on the height as well, I can just change it from saying height equals 3 to input and another prompt. So I could say enter the triangle height, colon space, and close that. Put a semicolon on the end because we don't need to see it. And there you go. Then we're calculating the area of the triangle. But of course, if I go ahead and I run this in the command window, it says enter the triangle base. I can say 8. It's done because it didn't save for some reason. So let's save it manually. Run it again. Triangle base 8. Enter the triangle height. I can say 5. And then it ends because I'm not outputting anything. So if I wanted to see the final calculated area, of course, I could take away the semicolon on the end, right? And so I can do that, hit save, come back over here, run it, triangle base 8, height 5, and it says that the area is 20, right? But the only reason it says area equals 20 was because I took off the semicolon off the end, right? So there's another thing you can do, which is a display function. So we can use this function to display a specific piece of information on the screen, and it has nothing to do with semicolons or not semicolons. So I could right here, instead of saying, well, I could put a semicolon here, and then I could say display, and I could just say, what did we just calculate, right? The area is, and then like that, and you put it in quotes again. Single quotes or double quotes will both probably work here. So the area is and then I could display, and I could display the area, something like this. Now, these are not the only commands that we have available to us to display things, but these will work. So if I save this, I'll try to run it from here. Enter the triangle base, 5, enter the triangle height, 4, and it says the area is 10. Now, because I use these in 2 lines, it shows up as 2 lines, which maybe is not what you would like to do, but this is kind of what we have available. Okay, now the next topic, I'm going to try to fit this on the page a little bit better. All right, so the next example here is pretty much exactly what we just did, although the wording is slightly different, right? So it says triangle area script, b equals input. So you can use input when you need the user to type in a variable. So they're typing in the base, they're typing in the height. The area is 0.5 times b times h. As you can see here, I typed 1/2. And then display the area is and the area, right? So this is the same as before. Now, these commands here that I did not put semicolons on could have semicolons, and that's perfectly fine, because if you do that, and you put in some numbers here, you can see that it's still going to print out, even though you have semicolons. That's because the output that's suppressed when you put a semicolon on the end of things are things like what the function returns, if you know what a return value is. We don't know about functions yet, but if you do, then that'll make sense. However, the function display, disp, was going to output something to the screen, and it's going to do that no matter whether or not there is a semicolon on the end. So that's not the same. Like, you can't suppress the output of a display using a semicolon, because the whole purpose of a display is to output something. Okay. Now, the next topic that we want to look at is going to be arrays. Now, this is already in a different section, section 4.2. Now, it might seem like we're skipping a chapter here because there's chapter 3. However, chapter 3 is basically just like writing a script like this, although a bit more complicated. And I don't really want to do that right now. So we're jumping to chapter 4, and we're doing a couple sections from there. So the first section that we're going to look at is essentially section 4.2. And what we want to look at is how to create a vector or an array. So they're going to be called different things depending on the programming language you're using. And in MATLAB, this would often be called a row vector. It's a row because the alternative would be a column. So if the numbers are horizontal, it's a row. And if the numbers were printed vertically, it would be a column. So that's why we're calling it a row vector. And it's just a list of numbers. In other programming languages, they might call that an array. So that's why it says working with arrays, which I think is what the section is called, or similar in 0 to MATLAB. And but other programming languages might call it an array. In MATLAB, it would often be called a vector. Doesn't really matter in this case for us. Now, to show you what that looks like, I'm going to head back over to Octave here and go to the command window, and I'll just clear the screen. And we can type one in. So if you wanted to type in a row vector, I could type it in exactly the way it shows here. So in square brackets, I could just put numbers and have commas between them. So 579. There you go. X is 579. Now you could also type it in with spaces. So just 579. And you don't need any commas. And that will also produce a row vector. Okay. Now it's beyond the scope of today's lecture, but the reason this is a row is because it's horizontal, as I said, and there are column vectors as well. And so what would happen is if you used semicolons, so like 5 semicolon 7 semicolon 9, that would create a column. Or you can do 579, that's going to be a row. However, if you put an apostrophe on the end, that is what we call a transpose operation, and that will turn a row into a column or a column into a row. So that's another way to do that. So MATLAB has rows and columns because it's designed to work with matrices. And for now, we're only working with rows. So that's why this little section here in the notes is labeled as row vectors. Okay. So with that said, I'll just do 579. 579. So there you go. That's how you can type one in, and you can assign it to a variable. Now, once you have a vector or an array, then you can access specific elements of that array using the name of the vector, in this case x, and then parentheses, and you just put which value you want. Now, in this one right here, x579, so if I do x parentheses 1, you can see that that's the 5. And if I do x parentheses 2, that's the 7. And if you do x parentheses 3, that's the 9. Now, I have a word of caution here, which probably should be here, but it's not listed as a caution. But MATLAB uses one-based indexing. That means the first element starts at 1. Other programming languages don't do that. So if you're learning programming in Java or C++ or Python, anything pretty much, like the way you would access the first element would not be x1, it would be x0 in other programming languages. So like you would type x0 and that would show you 5, but not in MATLAB. MATLAB's kind of a weird programming language in that respect. So this is important, so you want to remember it. The first element starts at index 1. Okay? So it's pretty easy to access elements. Like we have this x here. I can say x, 2, and that's 7. But not only can you access them that way to use them for things, right? Like I could say, 7 times x1, right? And that's 35 because x1 was a 5, right? You could, do 7 times x1 plus x3, right? So you can use every entry of the array as if it was its own variable, right? x3 is just a 9, x1 is just a 5 for this x, okay? But you can also modify the vectors as well. So if we know we have the vector 579 here, and you say, well, what if I want to change that 7? Well, the 7 is in element x2, right? So x2. And what do you want to change it to? Well, you could say, I want to change it to 9999. So you just have to say x2 equals 9999, and then suddenly the middle entry is 9999. Right? So it's very straightforward the way that you deal with vectors or arrays in MATLAB. It's a pretty simple method of accessing those elements. Okay, but MATLAB is designed to do things for math, right? Specifically. And so a lot of times you don't want to be able, or you don't want to type in your arrays directly. You want to use kind of some command that can create an array that you want. And so the next thing here, number 4, says the colon operator, section 4.5 in 0 to MATLAB. This is a shorthand notation for creating specific vectors. So how does it work? Well, I'll show you here. So stop. Just stop highlighting things, please. Okay, thank you. So if I say, x equals, and I type in a number, like what if I want the numbers like 1 through 5? I have to go 1, 2, 3, 4, 5, right? And that's x. But there's another notation that uses a colon. So if I wanted to create the vector 1 through 5, I could just write 1, that's the starting number, colon 5, that's the stopping number. And if I do that, magically y is 1 through 5. So that makes it really easy to create vectors that count basically. So you could say x equals, let's say, -5:5, right? What would that be? -5, -4, 3, 2, 1, 0, 1, 2, 3, 4, 5, right? So you can create a vector quite easily that starts at a specific number and ends at a specific number. And you can see that the spacing between these numbers is 1. Okay, so that's the first thing you need to know. The second thing you need to know about this is that instead of just using 2 numbers, you can specify 3 numbers. So you could do something like this: x equals -10 colon 2 colon 10. So what will that do? Well, we've got 2 colons. Well, if you look at this, you should be able to figure it out. You can see that the first number is still going from -10, and the last number is +10, which is where we end up. But this time, we're counting up by twos, right? -10, -8, -6, -4. So the spacing between each of these numbers is 2. And so that's what the middle number does there, is it specifies the spacing. Okay, so again, not hard to use and very useful. So they explain that here. 1 colon 10 should be 1 through 10. And then 1 colon 2 colon 10. That's going to be odd numbers because we're starting at 1. And that one actually illustrates something. So I'm going to type it 1 colon 2 colon 10. And what this illustrates that's kind of interesting is that the first number that we specified was 1, and we start at 1. And the last number we specified is 10, but we don't get to 10, right? And that's because if you think about it, if we start at 1 and we're counting up by twos, we're never going to get to 10, right? It'd be 1, 3, 5, 7, 9. The next number is 11. So 11's too big, right? Because we're supposed to stop at 10. So if we're supposed to stop at 10, this isn't going to go up to 11. But we're not going to hit 10 because if we're counting odd numbers, we're never going to get to 10. And so you don't actually get to that stopping number in every case, depending on what you're counting by. So if we're counting odd numbers, you're never going to get to +10, which is an even number. Okay, but we still start at the number on the left-hand side. All right. Now, what we're going to want to do now is think about how we can do operations with these vectors. So, like, let's say I type in a vector. I'm going to clear the screen again with CLC. X equals 1 colon 5, right? So I have these numbers here, and there's certain operations that you can do to them with math, right? So if I did this, like x plus 10, that's going to work. If I say x plus 10, you can see that what it does is it added 10 to every entry. So we had 1, 2, 3, 4, 5. If you add 10, you get 11, 12, 13, 14, 15, right? So subtraction works the same way, right? I can say x minus 10. Oops. X minus 10. um, so we wanted to subtract. If you typed it this way, you're saying x and then you're saying -10, which doesn't make sense. So that's a typo there. So if you do x minus 10, so 1 minus 10 is -9, 2 minus 10 is -8, and so on. And so you can process an entire array at once, right? So you can say like x equals, -10 colon 2 colon 10. So I got my even numbers. And then I can say y equals x plus 5, right? And I just get some numbers there. And you can multiply as well. So I could say y equals 3 times x. So you can multiply a number times x. And so there you go, right? Because the vector was -10 to +10, and then we multiply by 3. Now it's -30 to +30. Awesome. So what can you do? You can add, you can subtract. Somewhere we did that. I don't see it. Somewhere we subtracted. Oh, right here. Uh, you can multiply by a constant, and that's nice, right? But you have to be careful. You can't necessarily do everything that you think you can do. So, for example, if I have x equals, I'll just do 1 through 5, 1 colon 5. What if I want to square those? I want 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, right? One way to do that would be, you would think, x times x, right? So I want 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. But if I try to do x times x, I'm going to get an error here. And it says error, operator, multiply, non-conformant arguments. Op1 is 1 by 5, op2 is 1 by 5. So they're 1 by 5, right? They're 1 row and 5 columns. That's what it's telling you there. And it's telling you that you can't multiply a 1 by 5 matrix by a 1 by 5 matrix. And so you get this error. And so there's a way to do it though. So what you have to be aware of is that certain operations, if you're involving them with arrays and matrices and you want to do something element by element, you have to change the way you type it. So multiplication, instead of using standard multiplication with the asterisk, if you want to do element by element multiplication, which is what I wanted when I typed x times x, you have to type it with a dot. I've never seen another programming language use this syntax, but this is what MATLAB does. So if I want to actually do 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, I would have to type it as x dot asterisk x, and then it will square every element. Okay. So for multiplication with vectors, you might need to add a dot in front of the operation. Okay. Now, the other operations that have this issue, other than multiplication, are the exponent, which we type with a caret, and division, which we type with a slash. So the standard versions are times, exponent, divide, but you might need a dot in front of that to do element by element operations. And so just as an example of that right here, like let's say we have a function that we want to calculate. We want to calculate y equals 3x squared minus 2 for this vector, right? So let's think about it. I'm just going to type it out. So -2, actually I'm going to type it this way. -2 colon 2, right? So x is -2 through +2. And let's say I want to calculate this. And if you're not thinking about it, you would type y equals, and you would say 3 times x squared minus 2, right? That seems reasonable. But when I press enter here, I'm going to get an error. And it's the same error about, well, actually, it's a slightly different looking error. It says x to the y, only square matrix arguments are permitted. But it tells us what to do to fix it. It says use dot caret for element y's power. And that's also what this says is dot caret for element by element operations. So if we just retype this whole thing, I'm just going to press the up arrow and move over here and change that one operation to a dot, then everything will be fine. And now it'll properly calculate that thing for every element. Now you might question like, okay, why did the exponent need the caret, but this didn't need the caret? And so, or sorry, didn't need the dot. So the multiplication here does not need the dot because this operation is an operation involving an array. So we wanted to do the array x times the array x. And we did. But we had to use the dot. This operation, 3 times, is not a vector-vector operation because 3 is just a number. 3 is just a number, so it's a, a number times a vector. And if you think back to when we were just looking at the basic operations, right? If you have x, 3 times x is actually fine, right? X times x is where you get an error. So the 3 times did not actually need the dot, but the x times x basically does need the dot, right? So if you do 3 times x, that won't work. But the only one that needs the dot is this one. The 3 doesn't. Okay, so you need to understand that these element by element operations exist, just so that if you are typing something like this, y equals, oops, y equals 3x squared minus 2 to calculate a function, you just have to be aware that anytime it's a vector times a vector, you need the dot version. Oops, I typed the wrong thing. You need the dot version of that operation. Now, if you go ahead and you type an extra dot there, so you just do dot on all the multiplies and all the exponents, everything is fine. So it's not wrong to put a dot there on the 3, but it's just not necessary. And so you see what we just did right here. Now, the reason we're learning this, though, is so we can learn how to plot a function. That's the idea. Well, not the idea, but it's an idea. So, for example, you might, if from your math class, you might know that y equals 3x squared minus 2. That is a parabola, right? That's a parabola. So if we wanted to plot the parabola, how could we do that? Of course, MATLAB is good at this sort of thing. People used to generate like a lot of their plots in MATLAB because MATLAB allows a lot of control over exactly how it looks. So there's a lot of research papers that use MATLAB for plotting. Nowadays, there's so many different software that can produce plots that's not necessarily true in 2026, but it's still good at plotting. And Octave, copies everything about how MATLAB works as well as it can for plotting. And so MATLAB's good at plotting. Okay. But you have to have something to plot. And so there's this command called plot xy that produces a 2-dimensional graph. So we can do 3-dimensional plotting as well, but that's more complicated. Now there's a script here, but before we do the script, I'm going to show you kind of more basic usage of this. So just going to make this a little bigger. So let's say we did this, x equals, and I go, let's do -5 to 5, right? So I just have those x values. And now let's say I want to plot some kind of parabola. Y equals, and I'm gonna do x squared. So I use the dot caret for the x squared. And I'm gonna divide by 3, and then I'm gonna add 2. So what is this? This is just a function, right? So I've calculated this, and now I have x values and I have y values. So the way that the plotting function works in MATLAB is it assumes that you have a vector full of your x values. So I have one called x, and then you need a vector with the same number of elements, like y, with your y values. So I have all my x values and I have all my y values. And once you have a vector of x values and a vector of y values, the command plot x comma y will plot your function. So when we do this, you can see there we go. We have a parabola plotted here. Okay, now this is a very basic plot, and it's also a little bit blocky. So like if I were to, let's do a sine function actually. I don't know what kind of error message I'm getting here. I don't really care at the moment. I'm going to do this. So like, let's say I try to do a sine function this way. So I go let's say -6 to 6. And then I do y equals sine x. So sine is built in, so we can just run sine x. So I have y values. And then I do plot x comma y. And you'll see that you get a plot of the sine function, but that's like the worst sine function ever, right? And the reason it's the worst sine function ever is because if you look, we only used these x values. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. And so only 13 points appear on this plot. Only the x and y values we gave it end up in the plot. So there's like 1, 2, 3, 4, 5. I think there's 6 in the middle that you can't see. 7, 8, 9, 10, 11. Actually, I guess there's a couple. So there's 1, 2, 3, 4 is here, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there were 13 points plotted in this picture of the sine function, and that's not enough to make a nice looking plot. So you need more x values, okay? And that's why we learned about how to use this middle thing in the x, or sorry, in the defining our array. We learned that the middle term here in this colon operator allows us to specify the spacing, because now instead of using x equals -6 to 6 spacing 1, you could do x equals -6, and you could do, you know, spacing of 0.5 to 6. Now that's going to give you a lot, well, it's going to give you more x values, right? So we got 25 x values this time. But then if you do y equals sine x, and we plot x comma y, you can see that the plot already is looking a little bit better, right? Because we have more points. And we can do this again. We can do, what if we do spacing 0.1? We have 121 points, right? Which, by the way, if you are doing something like this, you might not want to see 121 points on your screen. And that's why we learned about the semicolon operator, right? So we use a semicolon, and we assume that that worked, and I can do y equals sine x semicolon, and we can assume that that worked. You can actually visually verify that it did kind of work, because if you look down here in the workspace where you can see your variables, you can see that x is listed as a 1 by 21, 1 by 121 vector. So that means it has 121 numbers in it. And y also has 121 numbers in it. So when I go to plot this, x comma y, I should have a nice smooth looking curve. And we do. And if it's not smooth enough, then you can just use more points, right? So you can always just go back up here, change that to, I don't know, 0, 1. Now look, we have 1,201 points. And if I do y equals sine x again, I forgot the semicolon. Now it has 1,201 points. So when I plot x comma y, now the curve has 1,000 points plotted, well, 1,200. So it should be perfectly smooth, right? And that's the basics of making a plot. Now, because there's a lot of stuff you want to include in a plot, titles and labels and so on, you want to use a script, something like this, in order to help you make a nice looking plot and to save you from having to retype things. So if I go here and I create a new script, which I can just hit Command N and get a new script, or File menu, new script. I can type my script right here, and I'm going to call this, I'm going to save it as, I'm just going to call it plot script. So plot script is right there. And what do I do in my plot script? Well, usually you can do things a lot of different ways. One thing you can do is you could say x equals, and then let's just say -10 colon 0.1 colon 10, right? So what is this going to do? This is going to basically set up my X values, right? Also, I can say what this does in a comment. I can say plotting script. Okay, so I can set up my X values. Then I can set up my Y values. Now, what function am I going to plot? Well, it's whatever one you want. I'm going to do this one. I want to do sine X divided by X. Now, this is going to be an error. Sine X is fine, X is fine, but in order to do division, if X has, 1,000 things in it, sine X has 1,000 things in it, and X has 1,000 things in it. So this is an array divided by an array. So what do we need to do? We need the dot version of this. So dot slash X. Spacing is not necessary. I put semicolons on the end of everything because I don't want to see it on the screen. And then I'm going to just do, what am I going to do? I'm going to plot my function. How? Plot x, y. My x values and my y values. Now we've used x and y every time, but just so we're clear here, these are variable names. So like if I called this A and B, and then this would have to be A and A, then what you would need here is A and B. You don't have to use the names X and Y. But I'll do that. So we have X values, we have Y values, we're going to plot the function. So right here, this is a good time to save it and then plot it and see what it does. And this is a plot of sine X over X. It's what they call the sinc function. Okay, so we have a basic plot. Cool. But we want more on our plots. And so looking back over here, there's things we can do to help make our plot look nice. And so it says add metadata. So we can give our plot a title and a label and a grid. Those are things that we could do. So those commands, going back over here, so we can just say like plot or matting. And so if we say title, then whatever is the current plot, it'll set the title. So I could say like plot of y equals sine x divided by x. Now this is just text, so we don't have to worry about dot slash there. So I can save that, run it, and you'll see, well, it's teeny tiny, so you probably can't read it, but there is a title there now. And we like to label our X and Y axis. So you could say just like X for the X axis and your Y label. Sometimes you label it just as Y. Other times you might label it with the function. So you could say like Y equals sine X again over X, or just Y. I'll just call it Y. And again, these are probably going to be teeny tiny and you won't be able to read them. But there is a Y there and there is an X down there. Another thing you could do is you could add a grid. I don't like MATLAB's grid, so I usually write my own function to do this. But you can see what happens now is now there's a rectangular grid over the thing. And so the point of having a script like this is if you wanted to plot a different function, all you'd have to do is come up here and change the X values and the Y values. And you wouldn't have to rewrite all this if you'd already done it. Although, maybe you should change the name of the function if you put it in the formatting here. So that's like the most basic way of plotting this. Now there's tons of other stuff you can do when plotting, like because like the line's so thin, you might want to make it thicker. That's something that can be done. I think I might be typing this wrong. Let's try. Nope, got it right. So I changed the thickness here and, because I can. So there are like a lot of ways to adjust this. I could do like 1.5 there, maybe. Another thing you can do is you can change actually the color and the spacing. So like if I say like M and I write a line, that's M is magenta. And when I run it, I should have a magenta line. Um, if I say like B, I think that's going to be blue. It is. So you can control things like that in your plot, although that's kind of beyond the scope of today. Another thing you can do that I use a lot, but not everybody does, is like when you do this and you produce your plot, like, okay, great, it's here. What if I need to save it, right? And so you can try to go to like file, save, um, but then you'd have to select the file format that you want and so on. Um, I'll just do it and you can have it saved there. But you can also put a command in your script to save it. And the command for that is print. Um, and so you just do print and you give it a file name. So I can call this like my plot, and I'm going to call it .png. And then you have to tell it what um, you have to tell it what format you want. And I think in parentheses, you do like DPNG is what I need if I want to save a PNG file. And what will happen is it doesn't print it anywhere. What it does is it'll show up over here. So notice that we have untitled PNG right now. So when I run this, if it ran, you'll see that I have that did not work. I typed this wrong. It's not the other way around. I know it's not. I'm gonna try my plot again. I don't, this can't be it. I haven't done this in a while, but I guess it is. Okay, fine. You win. So it's the file format and then the name that you want to give it. So I can open this. I think this will open hopefully here. Yeah. So you can see I opened a nice plot. And notice it does look better. It looks better in the saved file than it did when it was on the screen, and like the size of the title is visible and that kind of stuff. So you can save your plot that way in various file formats. And I like to put that in the code. And I just like to put it in the code because that way, like every time I change something, I get an updated plot, right? Like if I say, oh, I actually wanted this -20 to +20, right? Then I can change it and I just hit run and, we can see more squiggles. And I know that this is going to be updated, right? I didn't have to manually do this. It's just updated with the most recent version. So I prefer to do that. And so I tend to put something like this in my plotting scripts. Okay, so that was basically what we wanted to go over for today. And yeah, hopefully that was helpful. This is a Discord for an AI software company, which is, again, not what we want. So where where are we? We're in Safari, but not that Safari. This Safari. Okay. So that's it for today. And hopefully this was useful. And if you are working on the labs and you want a little bit more information, then this might help you finish up. Okay, so that's it for now. I will talk to you guys later.